All right, so we're going to do an example here. Given velocity is a quadratic equation and the position at 2 equals -3. So we want to find position and p of 1. The first thing I'm going to do is write down my velocity equation. All right, now I need to find position. So I'm going to write down my hierarchy of functions, and I'm going to note that if I am starting with velocity, I need to go backwards 1. Okay, backwards 1. So we have to do the antiderivative in order to get to position. Okay, there's that antiderivative rule. Add 1, divide by the same number. Okay, I'm going to keep my coefficient. Add 1, divide by the same number. Add 1, divide by the same number. Plus C. Okay, so before I move on to this initial condition, which is a point on the original graph, okay, I'm going to kind of simplify and rewrite this a little bit neater. Okay, so this right here is an XY point on position. Okay, so right here, these two things go together. So I'm going to plug in 3 for the Y coordinate and 2 for the X or the T. All right. Now we're just on to a little bit of arithmetic here. Okay, so C equals -1. So now I have found position. That's the answer to the first question. So position equals 5t minus t squared minus t cubed minus 1. So there's answer. Okay. And then the second part says, well, what is position of 1? That means that at t equals 1, position of 1 equals 2. Okay, so let's look at that. 5 times 1, 1 squared, 1 cubed, minus 1, all added up. Position of 1 is 2. Notice that this was a two-step process. First, I had to find position. Then I had to plug in. All right, I'm going to do one more example for you here. Let's say given A of t equals 2, okay, and velocity of, let's think of a good one, velocity of 0 equals 1, and position of 0 equals 3. Now, see here, when we use 0, that's initial, or V naught, if you want to connect that to physics. Initial position or initial velocity. That's the starting. Initial velocity. Okay, find, here's the question, find position and P of 1. Okay, Big questions. I'm going to write my hierarchy down. Position, velocity, acceleration. And this time I am starting at acceleration. So I need to go backwards, not once, but twice. And I'm actually going to go ahead and change our acceleration to 6t. Sorry for that. All right, so let's start at acceleration. Need to go backwards to velocity by using the antiderivative. So keep the 6. Add 1 to the power, divide by the same number. Okay, now I'm going to rewrite this, right? 6 over 2. Okay, notice here that we have a connecting, okay, see that? These two things go together. Velocity, velocity. Now you can write this as an XY coordinate if that helps. Okay. And we're going to plug it in. So 1 equals, plugging in 0 is always nice. Okay, so C equals 1. Okay, so let's fully write out. I'm not going to put it in a solid box because this is only halfway there. Right here. I need to go back one more time to find position. Okay, so backwards to position using the antiderivative rules. Okay. Okay, so now let's go ahead and look. I think we've got 1, there it is, P of 0. Okay, so this is the position. Notice P of 0 equals 3. You've got to make sure that you are connecting the correct points with the correct equation. So I'm going to go ahead and plug this in. So 3 equals, like I said, plugging in 0, super convenient. So position equals t cubed plus t plus 3. All right, that's going to get a big box because one of my questions was find position. Now the other one says find P of 1. That means that you want to plug in 1. Okay, so P of 1 equals 5. All right, there you go. Let's see, looks good. All right, guys, good job.